angle between two lines. So in this lesson, we're going to talk about how to find the angle between two lines. Now, earlier we actually found the angle between two vectors, which was this formula here. But if we want to find angle between two lines, what happens there? Well, when you find angle between lines, you actually have two options. You could find this obtuse angle right here, or you could actually find this angle right here, the acute one. Now, if you find one, when you do your problem, you could tell which one you need to actually know which one you found. Is it bigger than 90 or is it less than 90? If they want the other one, well, how do these relate? Well, they're supplementary. So let's say you find the acute angle. How do you find the obtuse one? You just do 180 minus that angle. If you find the acute one, they want the obtuse one, do 180 minus that one. I will say though, in vectors, they generally ask you for the acute angle between the two. So if you always want to get the acute angle, you get this formula right here, and you just adjust those slight bit, which is you make the top positive. It's a little confusing. That's actually absolute value. I know down here it's magnitude, but you take the absolute value of your scalar product, and that would always get you the acute angle. So most of the time they're going to ask you for the acute angle. Almost always they ask you for the acute angle. So if you want to force the acute angle, just make the absolute value of the top. If you don't really care which one you get, and then you just adjust it afterwards, you just subtract it from 180. So let's go here. Find an angle between lines L1 and L2. So usually when I find an angle between lines, I like to rewrite it first. So my L1, let's write it in vector equation form. It's going to be xy is equal to, now see this is in parametric form, we're going to rewrite it in vector equation form. So my x's are 2 and 3, negative 3 actually, and my y's are negative 1 and t. So negative 1 is my constant, that's going to go with my initial point, and then this is my direction vector, so that's going to go down here in my direction. So the constants are your initial points, so 2, negative 1 is my constant, and my direction vectors are the things with the variables, so negative 3 and 1. So this is my direction vector. So that's the line, that's a vector equation of L1. L2, now you kind of know the gist, same idea. We're going to take the constants, so 1 and negative 4. We'll add in the direction vector, which is in this case 2 and 3. And now notice if I'm writing the x on top like we should, and writing the y's on the bottom. Now if I want the angle between these two lines, this is a very important concept. You do not care at all about the initial point. That does not tell you what your angle is. What tells you the angle is the direction vector, right? The slope of these lines. So we're only going to care about these guys, right? Our formula for this is cosine of a dot b over magnitude of a, magnitude of b, right? That's the equation for the angle between two vectors. So we're only going to care about, this will be my a and my b. It's a direction vector. That's all I care about. So let's say A is this one, B is that one. That's all we're going to care about. We do not care about the direction at all. It's just there to mess with you. So we don't care about the initial point at all, sorry. We only care about the direction. So let's do this. Now, if I want to just find the angle between lines, so I'm just going to leave it like this. So my A, let's do A dot B first. Remember, all we do is multiply the corresponding parts. So negative 3 times 2 plus 1 times 3. I get negative 6 plus 3, which is negative 3. I'm going to find the magnitude of each one. Magnitude of A is square root of negative 3 squared plus 1 squared. So 9 plus 1, which is rad 10. Magnitude of B would be square root of 2 squared plus 3 squared, which get me rad 4 plus 9, rad 13. Now, let's get to this in a second. Let's plug it all in. Now what I was going to say is, notice how this is a negative on top. I tell you right now that I'm going to get an obtuse angle from doing this. If you want to make this the acute angle, just the absolute value, just put a 3 on top. Which again in vectors is what they generally want, what they generally ask for. So I'm going to do that here. I'm actually show you the negative 3 first without because I want to show it to you. So I typed it in already. If I plug this in, hit enter, I'm going to get 105 notice obtuse angle. What if I do it like the way vectors generally want, which you take the absolute value on top, so you want to get the acute angle. Just to show you how it works. If I do that and delete this, I'm going to get 74.8. If you add these two up, you get 108. So they are supplementary. So in this case, let's say, again, for vectors, they generally want the acute angle unless otherwise stated. So we're going to say 74.7 is the answer. Let's move on a bit to talk about what's coming next. A couple things about these lines. So if our lines are written like this, right? Keep in mind, A is the initial point, B is the direction vector. And like I said earlier, it's really all about the direction vector. A is the initial point, it's nice. When we care about things, when we care about angles, it's all about the direction vector. So like, how do I know if two lines are parallel? Well, I check if the direction vectors are parallel. Just to give you a quick example, if I gave you r1 equals 1, 2 plus t times 3, 4, and r2 would equal 3, 2 plus t times 6, 8. These are parallel because this is just a multiple of that one, right? If I multiply this vector by 2, I'd get this vector. So that's how you tell two things are parallel, if their directions are parallel to each other. Remember, parallel just means one's a multiple of the other in vector notation. How I tell two things are perpendicular? Remember, perpendicular is when you take the dot product equals 0. Well, again, I only care about the direction vectors. If I take the dot product of two things on two directions and I get that to equal 0, then the two lines are parallel. So let's do another example here. So I want to find the angle between the lines. So remember, the angle between lines is just the thing we did earlier, cosine of alpha times beta, or magnitude of b, or magnitude of b. And if I want the acute angle, we'll do this absolute value, just make it positive. But remember, it's done the same way. I only care about the direction vector in these. So this guy, we'll say this guy's my A. We'll say this guy is my B. Right? I know it's in 3D. Does not change a thing. So let's first find our A dot B, or alpha dot beta. So we multiply the x values, so -3 times -3. Multiply the y values, 1 times 1. And multiply the z values. I get 9 plus 1 plus 4, or 14, sorry. And then I gotta do magnitude of A, magnitude of B. Magnitude of A is -3 squared plus 1 squared plus -2 squared. 9 plus 1 plus 4, so it's 14. Rad 14. If you notice, they have the exact same. They're parallel. They have the exact same thing. So B is gonna be rad 14. They're the exact same angle. So let's type in and see what happens. So I'm going to get cosine theta is equal to 14 over rad 14 times rad 14. Cosine theta equals 14 over 14 because the radicals cancel each other out. And I get cosine theta equals 1. Remember where cosine equals 1 at? Right here. At 0 degrees. That's the answer. And really, like I told you that from the beginning. If two vectors have parallel direction vectors, then the angle between is always going to be 0. So you can tell these two are parallel, automatically 0. So let's do the next one. Find the measure of the acute angle between the lines here and here. Now this one's a little tricky because you look at, wait, I have two lines. How do I make a vector equation out of this? Well, really, all we care about is the direction vector, which is another way of saying the slopes. So basically I gotta find the slopes of both of these guys to find out what the direction vector is. So over here, let's put in the slope intercept form. Y equals -2x plus 5. Right, just get y by itself. So the slope here is -2, also known as -2 over 1. Now I talked about this in an earlier video, but remember, slope's a little weird. So, well, this concept's a little weird. So slope is a y over x value. If I want to write that as a vector, though, as a vector, let's say this is vector A. The vectors are x over y, so you got to flip that and make this the direction vector, 1 over -2. Because the vectors are xy, slope is yx. So the vector equation for this line here would be like something like this plus my initial point, which I could plug it in and find it, but it does not matter. If you want an initial point, you can plug in like 0 and you get the point 0.05. But all I really care about is the direction because all I care about is the angle between them. Now let's do the same thing for B. Right, I can get y by itself. So let's say -2y equals -3x plus 8 divided by -2. Y equals 3x over 2 minus 4. So my slope here is 3/2, which makes my vector for B, my direction vector for B, 2 over 3. Because again, vectors are x over y, slope is y, so y over x value. So these are my direction vectors for A and B. Now again, if I wanted a vector equation, I'll need to find a point. Really easy, just plug any point you want in, plug like a 1 in, get the y value. That's your point. And all we care about here is the direction vectors. So now we can find the angle between them. Right, angle between two vectors, cosine of theta equals A dot B over it actually said acute angle, so I'll do absolute value. A dot over the magnitude of A and B. So let's do the dot product first. A dot B would just be multiply the corresponding parts. -2 times 3. That's an ugly -2. So I get 2 plus -6, which is -4. Gonna need that absolute value. Magnitude of A would just be square root of 1 squared plus -2 squared, also known as rad 5. Magnitude of B is going to be 2 squared plus 3 squared, which is radical 14. So my formula sheet, plug it in, we get this. It's value -4 over rad 5 times rad 14. Let me simplify this to make this a little nicer. It'll be 4 over, that's what, 60? 5 times 70. Ooh, that's embarrassing. There we go. So then I set the cosine inverse of both sides and get my answer. Type it into my calculator real quick. Like that. Done off screen. And I get 86 degrees. 86.7 degrees. 3 sixes. Remember, that is the acute angle between these two lines. If I want the obtuse angle, just subtract from 180. But yeah, so that's the idea when you have lines. How do you turn lines into vectors? Well, in this case, I just cared about the angle between them. So all I really wanted was a direction vector. So you find the slope, y equals -2x plus 5. Rewrite it. So remember, vectors, slopes are in y over x, but my vector direction vector is in x over y. So you have to flip it, and that's your direction vector. If you wanted a vector equation, just for quick, right? So that's like r equals a plus bt. Let's do it for a. Let's do it for this guy. Well, I already have the direction vector, -1, 2. So I'll do it up here real quick. So my equation would be like this: 1, -2 with the t. How do I get initial point? Well, you can use any point you want. I said this earlier, just use 0, but you can use anything. You can like plug in 1 for your x. What would that make your y? -2 plus 5, 3. So my initial point here would be 1, 3. If I use 0, it would be 0, 5. And that'll be the vector equation of this line. You find the slope, flip it because that's be x, y. If you want the initial point, you can use any point you want. Plug in 1, 2, 3, it doesn't matter. Plug something for your x, get the y, and that's your vector equation. That's this video.